Alright, so now that you've seen four different forms now, so we'd seen standard form, factored form, vertex form, and recently you saw partially factored form as well. We've seen four different forms of a quadratic to work with. A couple things to recall now before we start looking at how to move between, again, between these forms into vertex form. So one thing we saw that the a value from standard form and vertex form was always going to be the same. Not necessarily the case for factored form and partially factored form, but will always be true for standard vertex form. And we saw with factored and partial factored form that the advantage of it is we can either determine two symmetric points, either the zeros or two other points at the same y-intercept, that allow us to determine the axis symmetry, which we could then use to find the y value of the vertex. So just for an example here, let's say you have one in factored form, x plus 2, x minus 3. Right away you could say, oh, that's factored form, so I have two zeros. And those zeros would be at -2 and +3. Okay, if you were to look at one in partially factored form, let's say we had, I don't know, y equals 2/3 3x plus 1 x minus 4 plus 7. Now this is in factored form, this is partial factored form, and this doesn't give you the zeros anymore, these factors right here, the 3x plus 1 x minus 4, but these x values here, you're going to get x values of -1/3 and 4. They're not the zeros, but they both have a y value of +7. So even though these aren't the zeros, they're still useful because you can use these two x values right here to find your axis symmetry, and you can then use that axis symmetry to find your vertex, or the y value of the vertex. Okay, so that's the useful part of partial factored form and factored form. Okay, so let's try and put this to use. A good chunk of the lesson today is really just trying to move from some of the different forms we've seen into vertex form. So the first couple we got here are factored form. I would like you to try these on your own first. Again, try to find vertex form. And again, I'll let you guys think through the steps to find that. Think to vertex form, you need to find the vertex. How am I going to find that from factored form? So give them a try and push play and ready to go through the answers together. Okay, so at the very least, check your answer for A right now. You should get 2 bracket x plus 4 all squared minus 98. To go through the steps of how I got that, first off, I found the zeros from factored form here. My zeros were +3 and -11. And I averaged those out to find the axis symmetry, wound up being a -4. So the axis symmetry is the x value of the vertex. I wanted to find the y value of the vertex. I threw that into the original equation for x. So that happened right here. Okay, I solved for y and I got a y value of -98. So when I put that together, the axis symmetry, I got my vertex at -4, -98. So then I got my h and my k value to put into vertex form. So that took me down to here. So then I need to find my a value. Now, to find your a value, there's a couple ways we can go about it. The way that most of you probably tried was to sub in a point. So a point that we haven't used yet in vertex form, if we go back to where we started up here, we have two zeros here. So you could either sub in the point, use the point 3, 0, or the point -11, 0. Okay, either one will work. I chose 3, 0 only because it was a little bit nicer number to work with. So I threw in 3 for x and 0 for y, and I did some algebra here and solved the equation for a, and that gave me an a value of 2, which I then put into the equation. Now, alternatively, if you didn't want to go through this process, one thing, if you remember from last lesson, or that one that we talked about here, the a value from standard form and vertex form is the same. So we don't have standard form right now, we have factored form, but we can actually take a quick little step here and put this into standard form if we want to find our a value as well. So there's a potential aside down here. If you want to find the a value, you can take the original equation, expand it and simplify. So I took x minus 3, x plus 11. I didn't show it, but I put it into an array. And when I expanded and simplified, I got x squared plus 8x minus 33. Then I multiplied the 2 into the equation to get 2x squared plus 16x minus 66. And then from standard form, I could get my a value of 2 and put that in there as well. So either way will work. It's just a matter of what you're really more comfortable with. One thing that you might find a little bit faster, if you are just trying to do the second method here, try and find the a value in standard form, you don't need to do the entire expansion to get into standard form to see the a value. All you need is a coefficient of x squared. So if you see this pattern, what you can do is you can take the coefficient out in front here, 2, multiply it by the 1x and by the 1x here. So 2 times x gives me 2x squared. And then there's other parts in standard form as well, but all that matters is the a value here. So that could be a potential shortcut there if I wanted to get the a value in standard form without doing tons of work. Okay, now it was a coincidence here that the a value in factored form, the 2 here, happen to be the same as the one in vertex form and standard form. That won't always be the case, as you'll see in the next example. Okay, so with that one done, again, hopefully you've tried the second one as well. If you haven't, please do so now. And again, in a few seconds, I'll reveal the answer to 1b. Alright, so there you have it. Again, I got my zeros here from factored form. I got zeros at -7/2 and 5. Found my axis symmetry, subbed the axis symmetry in for x into the equation, worked through the fractions, solved for y, got a nice optimal value of -289/8. Put that together to get my vertex. That gave me the h and k for vertex form. And for the a value, I did exactly what I did before. So there's 2 options. I could sub 5, 0, or the other x-intercept, but let's avoid fractions. You could sub in 5, 0 for a point for x and y and solve for a. Or I could take the original equation and find out what the coefficient or the a value would be in standard form through some quick little expansion. I didn't do the whole expansion. I just took the coefficient in front here, the 1, multiplied it by 2x, and multiplied it by x in here, which gave me 2x squared. So I knew my a value in standard form would be 2. Okay, so when all is said and done, I get that as an answer. Okay, so that's a couple of examples of going from factored form into vertex form. Now let's look at a couple where we're going from partial factored form into vertex form. Okay, so same idea here. I'll run through the first one quickly with you guys and let you try the second one on your own. So again, with partial factored form, we have what looks like some factors here, but these factors are not going to give you the zeros anymore. If this were factored form, this -6 were in here, for example, let's just pretend that wasn't there. You would say this function or equation had x-intercepts at x equals 0 and x equals -10. Okay, however, that +6 that's there, or sorry, that -6 that's there, that changes the equation. It shifts everything down 6. So instead of these being zeros, these x values, what these are x values of the points when y equals -6. So instead we have our points at 0, -6, and -10, -6. Okay, so why is that important? Well, what's the purpose of having points with a y value -6? Well, the y value is irrelevant. What matters is that the y value is the same for each of them. Because both the y values here are the same, they're both -6, these x values right here, just like the ones we get from the zeros in factored form, can be used to find our axis symmetry. So we can take excuse me, these 2 values. Axis symmetry will be 0 plus -10 all over 2, which gives me -5. Okay, and then right from here I can do exactly what I did before. Sub the axis symmetry into the equation, solve the y value of my vertex, and start creating vertex form from there. Okay, I'll let you try and finish that one up, and then try D, and we'll go through the answers together in a minute. Alright, so take a second to check your answers there. I'll just run through the steps. The steps are the same for each one. So once I got my axis symmetry for C over here, subbed into the equation, I got a y value of -81, and threw that into the vertex form for h and k. Now, to find my a value of 3 here, didn't come from nowhere, so I could do one of 2 things. I could sub in a point. I could either sub in the point 0, -6, or -10, -6, sub that in for x and y, and solve for the a value to be 3. Or I could look at the this one, right, the original equation right here, and try and put it into standard form. So if I wanted to quickly put this in a standard form, I would have 3x times x plus 10 minus 6. But if I'm just looking for the coefficient, the a value, the coefficient of x squared, I would just do 3x times x, which is 3x squared. Okay, and there is more to it, obviously. You can expand and simplify the entire thing and find the answer. But again, all I'm concerned about here is the a value, so I can stop there once I found that. So that a value is 3, and I get my equation vertex form. Okay, with D, the process is the same, just with a little slightly uglier numbers. So with each of these factors here, you wind up with points x value of 1 over 3 and -3 over 4. The y value for both of these is 7. So we can use the x values to find the axis symmetry. The axis symmetry is slightly ugly. It's -5 over 24. Throw that into the equation for x. Do a lot of fraction work and get 167 over 48 for your optimal value. throw that into the equation for h and k, and then again just a matter of finding the a value. So once again, I could sub in one of these points if I wanted to for x and y, or look at the original one. So here, in standard form, I have an invisible 1 out here, so 1 times 3x times 4x would be 12x squared plus whatever else happens in standard form, but the a value in standard form is going to be 12. So I throw that into my a value for vertex form, and I'm done. Okay, so now we've looked at factored form to vertex form, partial factored form to vertex form. The only one that's really left is to go from standard form into vertex form. Okay, so when you're looking at both of these, let's take a look at the first one right now. So I've got 4x squared minus 12x plus 5. If I want vertex form, as you know, I need the vertex, which means I need either, so it means I need the axis symmetry, which means I either need zeros or two symmetric points. If I wanted to find the zeros, I'd have to put it into factored form. If I didn't care about whether or not it was zeros or two symmetric points, I could use partial factored form. Okay, either one of these will work. Okay, so why don't you try with each of these two to at the very least start by putting it into either factored form or partial factored form, and then see if you can go through from there. Okay, so again, try putting them into either factored or partial factored form, and check your answers in a sec. Alright, so for the first one here on the left, I've looked at two different ways. So I first of all tried to put it into factored form. So I threw it into the array, and I found I needed two numbers that multiplied to 20 and added to negative 12. So those two numbers were negative 10 and negative 2. So I factored this into 2x minus 5 and 2x minus 1, got my zeros of 1/2 and 5/2, and then in theory from there I could do exactly what I did in one of the earlier examples. I could find the axis symmetry, the optimal value, find the vertex. I have my a value already because I started with standard form, so my a value in vertex form would be 4, so I could create vertex form with only a couple steps from there. Alternatively, if you want to instead do partially factored form, okay, reminder we did this briefly last lesson, is to partial factor it, we look at just the first two terms. We're going to ignore that plus 5. Just look at the first two terms and common factor them. So what do both those terms have in common? They both have a 4x in common. So if we factor out the 4x, we're left with x minus 3 left over. Okay, so in that one step, we've gone to partially factored form, and now we have 2 points we can use, 0, 5, and 3, 5. So I can use those two x values there, 0 and 3, to find my axis symmetry, and then again find my optimal value, my vertex, take my a value of 4, and create vertex form. So I'm not going to go through all that. We've done enough of those today, but I'll leave it to you guys to practice it to make sure you get the right answer. So on your own, make sure you can put this into vertex form. You should get 4 bracket x minus 1.5 squared minus 4. Okay, with the one on the right though, let's see what happens. Well, first of all, if you try to factor this, it's really tricky when you're trying to factor this and you're involving a fraction here. If you want to, you could factor out that negative 1 over 2 as a common factor. Might make things a little bit easier. So if I do this, I'm going to have x squared. Now, how many times does a half go into 7? Well, a half goes into 7 14 times. So if you take a negative half 7, you'll have x squared minus, 14x. Okay, then a half goes into 3 6 times, so you'll have minus 6. So with x squared minus 14x minus 6, where you're going to run into a problem here is you're going to run into an impossible situation to factor. You need two numbers that multiply negative 6 and add to negative 14, which does not happen. Okay, it's impossible. So this does not factor, which means putting it into factor form won't be an option. So you're going to have to do partial factor form here. It's going to be your only choice. Okay, so let's start again. Let's try and do this one in partial factored form. And again, just looking at the first two terms, I'm going to common factor them. So what's common between negative half x squared and 7x? Well, I'll take out negative a half x. I'll be left with x minus 14 with that plus 3. So this means I'll have points at 0, 3 and 14, 3. Okay, so from here I could find the axis symmetry, and the vertex, and then find vertex form. So again, I'll leave you to practice that to make sure you can get it to work out. But again, just note that some equations in standard form do not factor, so you have to use partial factoring in order to try to get into vertex form. Okay, so we'll continue this in part 2, and we'll see you over there.